Hey, this is Charlie Thompson, and I wanted to make a quick video about wind and air pressure patterns and include some different examples. That way, if, let's just say, hypothetically on the midterm, you saw a different kind of diagram than the exact same one in the book, you won't be alarmed. You'd say, oh, yeah, I've seen diagrams like this. I get the general idea of what's going on. It's not exactly what I looked at before, but I've got the idea. Everything is connected. Everything in physical geography is connected to everything else. And I think that's one of the difficult things as a student because it's like drinking from a fire hose. There is so much new information coming at you all at once, and it's really hard to see how everything fits together, but it does. Everything is connected. This is why, for example, I keep saying you can't forget anything in geography. The concepts that we talked about in the introductory chapter in chapter 1 are related to chapter 2. Those are related to chapter 3. The patterns of high and low temperatures are going to be related to regions of climate, are going to be related to wind patterns, are going to be related to weather. And then later on, those are going to be related to the plants and the animals that live in that area. So, yeah, everything is connected. It literally is connected. In this case, everything is connected by flows of energy and matter, but everything is still connected. So, because Earth's surface is curved, different latitudes get more or less energy on the same day. This creates an energy imbalance between the tropics, which are hot with lots and lots of energy, and the poles, which are cold with little energy. The energy imbalance between the tropics and the poles creates weather. Wind, ocean currents, hurricanes, all of those act to transfer energy from the tropics to the poles. This creates climate zones. Let's go over some of the air pressure belts and cell systems on this diagram. So, number 1, we've got the ITCZ, the Intertropical Convergence Zone, where air is flowing along the surface, coming together right about the subsolar point. The ITCZ follows the subsolar point. It shifts north and south. We've got the polar high pressure cells at both poles. The polar high pressure cells, there's cold air, it's sinking, it spreads out, and it rotates clockwise in the northern hemisphere, making the polar easterlies. The westerlies and the polar easterlies come together. The warm air flowing over the ocean picks up moisture, gets really moist, runs into this cold air, gets lifted up because warm air is less dense. And as the air rises, it expands and cools, and so we get storms along the polar front. And then we've got the high pressure cells, the Pacific High, and then the Azores or Bermuda High going on in the Atlantic. These 4 pressure belts are going to form the wind systems. Air flows from high pressure to low pressure. So we've got number 5, the polar easterlies. This cold air is sinking and spreading out, flowing back towards the equator. Polar easterlies. The westerlies are created by the subtropical high pressure cells. The westerlies are the prevailing winds in the mid-latitudes. The westerlies are the prevailing winds in the mid-latitudes, blowing from west to east as the air sinks and spreads out and rotates clockwise in the northern hemisphere and counterclockwise in the southern hemisphere. So the air spiraling out of the high pressure in the southern hemisphere creates the southeast trade winds and creates the westerlies. In the northern hemisphere, the air sinking and spiraling out of the subtropical high forms the westerlies and the northeast trade winds. Number 7, the northeast trade winds. This down here, these are the southeast trade winds. They are mirror images of each other, northeast trade winds, southeast trade winds. And then in the upper atmosphere, we have Hadley cells, where the air is rising and expanding and spreading out, diverging, and then sinking at the surface and diverging, eventually making the westerlies and the northeast trades. The Hadley cells. The Hadley cells are mirror images, huge rotating bodies of air rising over the equator, sinking in the tropics, rising at the equator, sinking at the tropics. And then over the polar fronts, over the polar fronts, we have the polar jet stream, that ribbon of high velocity air that shifts around, and the polar front kind of follows where the jet stream, the polar jet stream is. And I wanted to show you some of the air pressure belts. We just saw them before, but these air pressure belts correspond to general climate types. So we've got the ITCZ, where warm, moist air is rising, expanding, cooling. So under the ITCZ, you get daily thunderstorms. It's always hot and wet. The rising air that causes the rain in the ITCZ also means that the moisture is now gone from that air. So when that air sinks and heats up, it's pretty dry. So you've got air that had lots of moisture, it rose, it expanded, it cooled, that moisture fell as rain, and now you've got dry air sinking, getting heated up, which makes it even more dry. So the world's deserts are under the hot and dry subtropical high pressure regions. I mean, you saw from both GOES and also from earth.nullschool.net, the ITCZ, you can make a really good point, a good claim that the ITCZ is a belt of low pressure that encircles the equator. These are cells, these are regions in the Pacific and in the Atlantic of higher pressure. The polar front is more of a belt than a cell. This is the region of cool and wet weather, at least in the winter for us, cool and wet. And then finally, we've got the polar high pressure cells, which are centered over the poles. So those are really regions, they're cells. Not a lot of energy, not super high pressure, but it's really cold and really dry up here under the polar high pressure cell. If you have sinking air, it warms up. Although it's still very cold, it got a little bit warmer. And as you'll see later, when air warms up, it gets drier. So I realized that it might help you to see what I'm talking about when I talk about these actual climate zones and how they map out onto Earth. So I found a picture of, this is NASA's blue marble. It's a photo mosaic of Earth. And if you look at Africa, it's a pretty good example of what we're talking about. So we've got the ITCZ, the subtropical high, the polar front, and then the polar high. So ITCZ, it's tropical rainforest, it's hot and wet. And then we've got the subtropical high, it's hot and it's dry. Then we've got the polar front up here where it's cool and wet, and we ran out of continents, bummer. And then finally up at the very high latitudes, we've got the polar high where it's cold and dry. So ITCZ along the tropics, along the equator, in between the tropics. The ITCZ along the equator, moving north and south with the subsolar point. Under the ITCZ every day pretty much is hot and wet. As we move away from the ITCZ, B, these are the subtropical high pressure cells in the Atlantic and the Pacific. Yeah, sorry about that angle. I just wanted to make sure that you knew I was talking about the high pressure cells, the subtropical high, where it's hot and dry because of that sinking air. Then we've got the polar fronts in the northern and southern hemisphere where it's cool and rainy. And then finally we have the polar highs where we've got sinking air where it's cold and dry, cold and dry. And this is a freeze frame from the GOES animation that we're just about to take a look at. I froze it because you can see the reflection of the sun, you can see the position of the ITCZ, and you can see that the terminator line is still tilted kind of like that, that the sun is still, it hasn't crossed the equator. It won't do that till the 21st of September, which is coming up. And on the equinox, the terminator line will run directly from the South Pole to the North Pole. It won't be tilted like this. It'll be more direct. And by the time it's time for finals, the terminator line will look closer to this as the sun will be down in the southern hemisphere. So let's take a look at some animation of GOES imagery. Okay, what we're looking at now is GOES Earth. This is the GOES 17 view of Earth. It's a 24-hour animation. And what I wanted to show you is the ITCZ, some of the rotation from this high pressure and low pressure and low pressure. So if the air is swirling around, rotating clockwise, like right in here, it looks to me like it's rotating clockwise. That's high pressure in the northern hemisphere. In the southern hemisphere, it rotates the other way. Over here, we've got air swirling counterclockwise. That's low pressure. Up here, we've got air swirling counterclockwise. That's low pressure. And all along the ITCZ, there's low pressure. So let's look at this in terms of pressure bands. So we've got the ITCZ with low pressure. Air is rising, expanding, cooling, making these beautiful thunderstorms. That air sinks in the tropics, and some of that air flows back, making the trade winds, flows back to the equator, and some of that air flows up towards the poles, where it creates the westerlies. So hopefully you can see in the mid-latitudes, the air is flowing from west to east. From west to east along the equator, it's flowing from east to west. And the polar easterlies are weak and pathetic. So they're not really pathetic. They're just weak because there's hardly any energy. It's cold. They get very little sunlight during half the year. So not a lot of energy. They have weak winds. I wanted to show you, that's pretty much it. You've got the cumulonimbus thunderclouds along the ITCZ, super distinctive. You've got some high pressure rotating clockwise and low pressure rotating counterclockwise. All right, let's take a look at the East Coast now. And if we look at the East Coast, things are similar. You can see maybe something forming out here in the ocean, rotating counterclockwise, so that's low pressure. And also in here, something's rotating counterclockwise. You can see thunderstorms, afternoon thunderstorms here over the Amazon. In fact, all the world's tropical rainforests are under the ITCZ because it rains every day. We've got thunderstorms in the southeast because they have a warm current. Nothing's going on. For us, we're not getting any rain. And you've got the westerlies, and maybe the remains of a tropical storm, and maybe the remains of a tropical storm, again, rotating. Oh yeah, it's fun when it switches from the visible to the infrared and you can see different details. Okay, that's good for GOES. Let's take a look at earth.nullschool.net and see how those two compare. Okay, so this is the view from earth.nullschool.net, and right now we're just looking at wind speed. I just wanted to give you a sense of the patterns. So we've got the southeast trade winds, we've got the northeast trade winds. I really enjoy looking at earth.nullschool.net because some of the patterns look exactly like the book and the diagrams, and some of the patterns, some places look like, what's going on over here? I don't know. It doesn't look all neat and tidy like the diagrams in the book. So we've got the northeast trades, the southeast trades. We've got the ITCZ with low pressure. We have high pressure here rotating clockwise, high pressure here rotating clockwise, really low pressure, really nice storm system right there. Another storm system here rotating counterclockwise. So yeah, like the westerlies, kind of like in there. I'll give you some westerlies. And the polar easterlies, they're not doing much. So let's turn on sea level pressure. And you can see that where it is, well, here's the ITCZ. It's slightly lower pressure. Here we've got some high pressure. It's white. Here we've got that first storm, the more distinct storm, showing low pressure there, rotating counterclockwise. Right next to it, there's high pressure rotating clockwise, and then more low pressure rotating counterclockwise. So you've got the northeast trades, the southeast trades, the ITCZ. That could be the Pacific High. And let's take a look and see what's going on in the Atlantic. And we should have a big storm over here or something going on. There you go. Low pressure, high pressure, low pressure. So this would be the migrating Azores or Bermuda High or Icelandic High, depending on where it is and what season it is. High pressure, this is also, you can see why the oceans are going to rotate counterclockwise in the northern hemisphere. This pattern is pretty normal. You're going to have storms like this move across, but for the most part, the patterns of winds, you're going to have the northeast trades, you're going to have the westerlies. Oh yeah, well, that makes a more compelling point Makes a better case for the existence of the westerlies. And then down in the southern hemisphere, we have high pressure. Here's rotating high pressure counterclockwise, high pressure counterclockwise, low pressure in the southern hemisphere is clockwise. So it's a good example of counterclockwise, high pressure in the southern hemisphere, clockwise, low pressure in the northern hemisphere. You can see low pressure over the Earth's tropical rainforests, low pressure, lower pressure, really low pressure. So this is the summer pattern of the Asian monsoon. There is higher pressure down here. The air blows across the ocean, runs into the Himalayas, gets lifted up, and you get lots and lots of rain with the summer monsoon. There's some low pressure up there. We could also turn on the clouds, the total cloud water. Often you can see, right, so here's the Congo, tropical rainforest, the African rainforest, the Congo. Indonesia, rainforest there. ITCZ clouds. Here's those two storms in the northern Pacific, 1 and 2. This one might work its way through this weekend. And then little puffy clouds, cumulonimbus clouds, some sort of tropical storm. I don't know what's going on there. And we're back to the Amazon. All right. Okay, this is a website called Windy.com, and it's got some really nice features. Right now, it's showing us wind speed, just like Earth.nullschool.net. It's got wind speed color-coded, and if you click on a location, it'll tell you what the wind speed is. So right here, it's 34 knots. Right here, it's 1 knot. And we can also look at it with air pressure. So there's air pressure turned on. So now we've got wind speed, we've got air pressure, and it's a really great place to play around with and try to cement these ideas that I keep talking about. Like in the northern hemisphere, high pressure rotates clockwise, low pressure rotates counterclockwise, low pressure counterclockwise, low pressure counterclockwise, high pressure clockwise, low pressure counterclockwise, high pressure clockwise. So here we've got the subtropical high in the Atlantic and some high pressure here in the Pacific. Up here, these areas of low pressure probably moving along the polar front. And if we move down towards the equator, we'll see this area of lower pressure. That's the ITCZ. You can see we've got the southeast trades, we've got the northeast trade winds. And the other thing that I wanted to make sure that you're aware of, and I think this is, again, a great resource because you can just click on it. So you can find the places where the contour, or the isobars rather, find the places where the isobars are super close together. You click there and the wind speed, well, actually that's giving us pressure. That is not what I wanted. So I'm going to go back to wind speed. There you go, wind speed. So you can find the places where the contour lines are closest. We click there. 35 knots where the contour lines are farther apart. Where the contour lines are farther apart. 8 knots farther apart. 1 knot close together. 31 knots. So where the contour lines are close together, where there's a very steep pressure gradient, right here. The lines are close together, 33 knots. Right here, looks like they're closer together. So you could even compare 24 knots, and then right here where they're farther apart, 4 knots. So this is Windy.com. The only thing I don't like about Windy.com is I can't select a date. So it always just shows like the current conditions in the forecast. It doesn't, you can't go back into the past like you can with Earth.nullschool.net. But this is Windy. I hope you play around with it. And I said I wanted to make a quick video. Hopefully that was a quick video. Hopefully you find the animations and the diagrams a little bit helpful. If you have any suggestions, please let me know. If you have any questions, please let me know.